flow equal to. Now we have to tell R, get the elements of the vector from the file pontelagoscuro.txt. This is what we have to tell R. The instruction, please read that file, is scan, which is intuitive scan. Now we have to give to R the location and name of the file, the address and name. Okay, so between commas, you have to write location, not location, your location, with capitals, and please use, instead of a simple slash, the double slash. I've not finished. And then name of the file. Of course, it doesn't work with me because I have to put my location. Just 1 second, because I have to find my location. Now I copied the file on my desktop, and now I write the location of my desktop. In order to check whether everything is correct, I suggest you, after the location, to write not the complete name of the file, just the first 2 letters, and then you complete with the tab. If the tab completes it, it means that it found it. Now let me press enter, and you see, read 30,850 items. You have to get there. So, we have 10 minutes to get there. Beware of the location, which needs to be your location. Don't copy my location. Yeah?
I get some problem because the double slash doesn't work on R, but I find another way on RStudio to scan them.
No problem. If you found another way, it's fine to me. And maybe with RStudio it's also easier. Once you succeed in getting it, please raise your hand and tell me. I'm fine. Okay, so you're fine. Okay, you're fine, correct. Okay. Fine? No. Okay. Yeah, because you didn't put the double slash here, so we need to do this. Where is the slash? No, this is action. Slash is here. Double slash. So, and also you didn't put the file. So you have to go here and then double slash again, and then go. Okay, this is why it doesn't. Okay, and also the commas. Commas here. instruction. Okay, okay, and I think you have to use the double slash in here, double slash, double slash, double slash, and then it works. Okay. Fine, yes, yes, okay. Okay. Yeah, does it work? Let me see. I think you put two commas, which is not what we want. And also you make a mix between double slash and and what is the slash? Double slash, yeah. Okay, so what about you down there? It's fine? This is a space. And let's try to complete it step by step. Because you see that in this equation there's several junctions, so we have to find the source. You have to find the complete. Anyway, you uploaded with RStudio. Okay, okay, perfect. Are you okay now? No. Okay, let me see. And the comma is no, it's not right. Okay, so basically we succeeded. One thing, so we were reported by her that with RStudio there is a easier way to do it, it seems. She didn't need to find, by using RStudio, the location. So this is something that it is useful to know, but on the other hand, I suggest you to learn also the console instruction, because otherwise you fall back in the situation where you use Windows, where you don't need to know basic instructions because you have a program that does everything for you, but you lose the capability of making more sophisticated and elaborated operations. Let me make an example with, it's completely different. If you learn driving with a car with the automatic gear, after a while you lose your ability to use the manual shift of the gears. And even if it is more comfortable and you don't need to use the manual shift anymore, then if you, for some reasons, you need to use a car with the manual shift, then you lost the ability to use it. And this is not what we want to do. We want to learn how to do things. And then it is useful that we know that there are softwares that can do the things for us in an easier way, but still we have to learn how to do things. Okay, so the console instruction is still very useful. Okay, now we succeeded in uploading the data. Now we are almost done. I tell you, this is the most complicated task of drawing the flow duration curve. We are not moving forward with the overall computation because it takes about 10 minutes and I don't want to keep you for 10 minutes more. But let me just show you a couple of very quick tests that you can make in order to see whether you successfully uploaded the data. Remember that when you deal with data, you have to be aware that something can go wrong with the data themselves or the operations that you did for uploading the data in the PC. So now we are sure that we are fine. Why is that? Because we are several people working on the same problem, and of course, if you got at this stage, I understand that you are already succeeded. But if you're working alone with new data that were not used before by anyone else, you have to be aware that something can go wrong. Therefore, when you work in your profession, it is extremely important that you avoid mistakes. Of course, and you are responsible for them. You cannot say, my PC did something wrong. In front of a judge, in front of a court, you cannot say, my PC did something that I don't understand. You are responsible for your mistakes, and therefore it is extremely important that you continuously check if you make mistakes, continuously. Every time that you have the opportunity to check whether you did a mistake, do it. Especially if it is easy to do it. And there are several tests that can be done very easily. And I want to explain to you a couple of them. Like, I upload the vector of Po river flows. Let's compute the average. Mean river flow. Look that I'm using the tab to complete. About 1500, fine, it's perfect. I know that the average of the Po river flows it's about 1500 of cubic meters per second. Very good. The maximum, max river flow. Almost 10,000, fine, it's good. And of course you don't have yet the skills to assess whether this value of the average and maximum are reliable, but you will learn them quickly. And one important thing, probably I already mentioned to you, the importance of the orders of magnitude. When you deal with data, it means that you are dealing with a real-world process. In our case, we are working on water. So when we get data, we are dealing with something related to water, which means a real-world thing. Get the perception of what is the configuration of this thing you are dealing with. Po river, okay, it's the largest river in Italy. What could be the average flow? It means to have an idea of the order of magnitude. It cannot be 1 cubic meter per second, of course. It cannot be 1 million. It is something that we have to get familiar with. This means order of magnitude. So the orders of magnitude is something that you have to learn for everything you deal with, because it gives to you the way, like here, to test what you're doing. If you have no idea of what you are dealing with, you have no way to test it. So numbers are not just numbers. For an engineer, numbers is something that you can see and you can perceive. So if you don't have any idea of the average of the Po river flow, what I would do is to go to Wikipedia and then look for Po river, and probably there is an indication of the average. Okay, I don't want to do it now because it takes 2 minutes. Okay, minimum of river flow. What could be the minimum? It cannot be 0, because we know that the Po river so far never dried up. So it cannot be 0. It is less than the average, of course. So it's something between 0 and 1500. Let's see. It's 170. Okay, reasonable. And once that you gain the idea of the order of magnitude of average, max, and mean for the Po river, keep it in mind. Not really the exact number, but something related to 1500 for the average, 100 for the minimum, 10,000 for the max, is something that you have to keep in mind. And immediately you have to relate it to the extension of the river and its location. Extension of the catchment. Look on Wikipedia, the catchment of the Po river is 70,000 square kilometers. So immediately learn order of magnitude and its relationship with the drivers. The drivers are the size of the catchment and the climate. Final thing, plot river flow. Let's try it. It takes some time. Let me look at the window. You see a plot. The plot, you see that it's barely readable. You cannot read it. So, what is your suggestion? My suggestion would be, let's use lines instead of dots. Okay, let's go back to R and let's use lines. Plot river flow, type, equal, double comma, L. This is the graph. Let me display together the graph and the instructions. Why the graph is useful? Because it's a way to check whether there is something wrong in the data. It's a visual way. Let's suppose that you get an outlier, like something that goes to 100,000. everything is limited to 10,000 and there is one observation at 100,000. It means that it's an outlier and we have to remove it. Or think about finding zeros. Of course, it is not significant, it is not meaningful because the polymer so far never dried up and then you have to remove them. It seems that everything is fine. So we are ready now, we have 90 years of data, we are ready for computing the flow duration curve. In my website you have an example of R5. If you want, you can anticipate me and move forward. And so the next time we will have something done. Next time will be in a couple of weeks from now, not next week. Next time for the PC, of course, because we will see each other on Monday for theory. Good.